Today, I'm going to introduce you to Neatoo. Neatoo is a domain model framework for .NET. It's designed to streamline object graphs that model behavior. It has a rule engine for business validation and operations that's triggered automatically on property change. These are tied to meta properties like isValid and isModified. And these in turn support parent-child relationships. So if your parent is valid, all your children are valid too. And there's an integrated data mapper that supports two-tier architecture. Neatoo is dependency injection in task, aka async await centric. The dependency injection provides unit testability and extensibility. You get async await everywhere in the authorization rules, the business rules, even async task property changed event handlers. What's really special with Neatoo are the Roslyn Source Generators. You can see and step through the code the framework is generating. You can see for yourself the decisions it made, and it gives you the best possible performance. All of this works wonderfully with Blazor. So that's what we're going to see now. We're going to create a simple Blazor standalone application that reads and writes to a SQL database using Entity Framework as the ORM. I won't take the time to explain everything. This is just a quick showcase of some of the features of Neatoo. So let's get started. So here's our simple model object to get us started. Person model with first name, last name, email, and notes. So we see I have an internal concrete, always internal with the public interface is the pattern. And the person model class that inherits from Neatoo edit base. And then as we define our properties, if we use partial properties, Neatoo will then automatically generate the getter and setter for us. So on the right, you are seeing the auto generated code by Roslyn. So this is the magic of Roslyn Source Generators. So we can define partial properties and classes. So now we see that we do a partial interface, and now our interface is also filled out if we so choose. So now we're going to create our first factory operation, and that's going to be create. So I'm going to open all the generated code. So all the code on the right is generated. So we see our factory and its corresponding interface. And we're going to add the create operation by adding an attribute, in this case to our constructor. So once we add that attribute, our factory will get a create method added, as I just highlighted in yellow. So now we'll go back to our Blazor Razor page and we'll use that new method to create a person model, or an iPerson model is what we receive. But we see a problem. Our create is not happy. First, I think maybe this is because I'm a task, but I'm not. So we can see the issue is that we're actually our method signature has a service. So this is where Roslyn is really nice, is instead of at runtime, you see issues at compile time. I don't mean to have this in my method. If I add the service attribute, as I should have had the first time, that disappears, and now my create will work. So now I add a couple fields just to see that I've actually created my object. I don't just have an empty form, just for now. Now we need to set up the server and client. So let's set up the server for dependency injection. So we need to do an extension method on our services, and then this is important. We label this to be the local. So this is the server. So all of the factory operations, the create, fetch, insert, update, delete methods will run locally because we're on the server. And then the other important piece is this next piece here. This is defining the controller, the one and only controller that all operations funnel through. So our server is set up. Now we're on the client. So this is a Blazor client. So the same thing, we need to register Neatoo, except this time we let it know it's remote. So if there's a remote option, takes it, and we defined the HTTP client. So that is injected, so you have full control of your HTTP client. So now that that's done, our create will work. So we open our app. we click create, and we get our breakpoint. This is actually running in the client still, and we get our object. So now we want to persist our object. So I want to add insert, update, and delete, which get exposed in the factory as a save. So I create my insert method. Then as soon as I create one, again on the right is our Roslyn Source Generator code by Neatoo. So we'll see there with that highlighted on the right. Once I have an insert, a save is created. But interestingly, since I just have an insert, I actually could get not implemented exceptions. So I could, if all I want is the insert, that is possible. But of course, I'll add a update and delete. And once I do that, now the factory, depending on the metastate of the object, will call insert, update, or delete. And our factory is complete. Again, this is all generated as we're writing our object. So now I go and grab the actual logic to do my insert. I'm using Entity Framework. Now we see another feature of Neatoo and the source generators. You can do auto mapping methods. So if I add a partial map to method, and I go and I open the generated code in the mapper, you actually see here that Neatoo has generated the mapping method for us, and you can see the decisions that it made. We'll see the throw null reference exception later. But again, now my insert method, all I need left is to save my context. There we go. Then I add the logic to my update method. And again, I'm using another Roslyn source generator from Neatoo that actually generates not just a map to, but it only maps the modified properties. So Neatoo keeps an is modified on each property. So now I can use that to actually update my entity in a more concise way, only including the is modified equals true properties. So there is my update logic. I do add the delete logic here. And then for the example, I just delete all persons every time I hit delete. Now I go back to my Razor page and I use the save method that's been added to our iPerson model factory to do the save. And then I get the object that's returned. So a save takes the object and it returns the object. In this case, it will have the new ID. And then we update our context. So here's something I forgot is I want these all to be remote calls. I don't want them to run locally. I want them to run on the server. So this is all we need to do to have a physical two-tier client server call. Nothing more. It's that seamless. So now I run the app. I do a create. I create a new object, but now I can click update. And when I do, so here I am on the client. Then when I continue, now I am on the server. And I can get my context. I can save it. Another neat thing with this Roslyn code is that you can step through it. So I'm now stepping through generated code. So my entity is saved. I wanted to see the ID, but I couldn't. But there is an ID there now. Now if I update it and I update again, even though I haven't done a fetch, now I will get to the update method. And this time I've chosen to just map the modified, and it can see that only the email was modified and proceed accordingly. So only updates the email property of the person entity, and now my object has been updated. But now that I can save, I need fetch. So I'm back in my person model to add a fetch operation. So again, we'll watch our Roslyn code to see the fetch operation the fetch method call be automatically added. We see they're highlighted on our right, and there it is. Now, normally with the fetch, you would have parameters. So in this case, I'm not going to, but if I logically were like an ID, once I add an int ID, then my method signature changes. So again, you'll get compile time errors if you change your method signature. In this case, I'm not. So I'll just grab my fetch logic and paste it in. Again, I'm using Entity Framework right in my data mapper method. So now here's an interesting point. If I weren't able to find my object, I just want to return nothing. And I accomplished that by returning a Boolean from my fetch. And if we watch our Roslyn Source Generated code, we see, oh, now it's a nullable. So now we can communicate to the client that we weren't able to find our object by returning a nullable object. So now, logically, if there's a map to, there's a map from. So if I add a partial void, I can map from an entity or an object, and it'll match up the properties that have the same name and generate a mapping method for me. So there's our fetch where we can read from an entity framework. I go back to my Roslyn page. And I added, and I forgot my remote attribute. So I go and add that because of course that isn't on the server, and we see our factory change. So now that I have my fetch operation and I go test it, run the application and I click fetch and I get an object. So now we're going to show a rules use case, and that's if I don't define first or last name. So those are not nullable in the table, but they're nullable in our object because we don't have initial values. So when I hit save, I get a null reference exception. So the first step is to use the required attribute. This is your standard system data annotation attribute, but that's also only part of the solution. To work with an edit context in Blazor, your object needs to be invalid when you go to save. I don't run the rules when you hit save. Now there's a lot of flexibility in this situation with how you would solve this. In this case, what I'm going to actually do is run the rules before the object is returned so that it is returned invalid and validated when the values are filled in. What that leads to is, since run rules is asynchronous, since our rules are asynchronous, I actually need to define a asynchronous create, which I cannot do with the constructor, but I can do it by adding factory method. Then my signature changes. And again, this highlights a wonderful thing with source generators is I get a compile error now because my create needs to be awaited. I go and I await my create so that those two required rules run before it returns. And now when I go and try to update or save a object without last name and first name, we get our broken rule messages or validation messages. So now I just click through and everything works. Clear it out, don't have a fetch. So now I create some data, go to update, broken rule. So now I update it, it works, clear it, fetch it, update the data, do an update, it succeeds, do a fetch, and I get the data showing that that's what was persisted. And then delete, do a fetch, I don't get anything back. So we have all of our standard CRUD operations completed with Neatoo, including a couple rules. So that's Neatoo. What do you think? Would you use it? Why or why not? Please let me know in the comments. And please check out my other videos to see authorization and business rules in action. Thank you for watching.